Transformation reflections notes. A reflection is a flip over a line called a line of reflection. Each point in this image are the same distance from the line of reflection. Showing you what they're talking about here to the side. Got two images here, pre-image, image. You should be able to tell by the way they're labeled. The line of reflection is here. You're flipping your image over this line. They're saying each point should be the same distance away from the line of reflection. Going to the left, A is the same distance away as A prime on the other side of the line of reflection. Same as B and B prime. Same as C and C prime. That's pretty much it. I mean, reflections are not that hard. Y'all just gonna make them difficult. Possible lines of reflection. The easy ones, the x-axis reflection and the y-axis reflection. And then we also have vertical or horizontal lines in the form of x equals a number, which for us will be a vertical reflection. And also y equals a number, which will be our horizontal reflection. We went over this yesterday though, if you were paying attention. And then you also have the diagonal lines in the form of y equals x, which is a slope-intercept form equation, and then y equals negative x, got the negative sign, minus x. That's negative x right there. Almost forgot the sign. Try to explain it the same way I explained it last class. The symbolic forms for this, you won't see, like if they're telling you to do a reflection, unlike with the translations, they won't give you a mapping rule to tell you to do a reflection, because the ones for translation just kind of tell you how to move left, right, up, down, or whatever. The rules for the reflections, they kind of tell you exactly how to do the problem. You can't really give a mapping rule for a reflection at the beginning, because you're just telling the person the actual coordinates. They'll just tell you in like a notation form. It'll be a capital R or a lowercase r. In this case, I'm going to give you two examples. Capital R, and then they may say reflect over the x-axis. That'll be how they write a rule for a reflection for you. Or you can see it as a lowercase r too. And instead of the x-axis or the y-axis, they may ask you to flip over the line y equals 3. But that is how you'll see your rules. But there are, for certain reflections, there are mapping rules. But like I said, they won't be given to you up front. You'll have to figure those out for yourself, and then you can use them if you remember which reflections to use them on. I'm going to help you figure them out when we do our examples down here. So that's pretty much the stuff you need to know for reflections. Down here we just need to start doing them so you can learn them. Examples: graph and label each figure in its image under the given reflection. Give the new coordinates. Start out, first figure is a triangle ABC with those vertices that they show you there. And they want us to do a reflection on the x-axis. First thing I'm going to do for y'all is highlight your x-axis so you know what you're flipping over. We didn't label, but y'all should still know what the x and y-axis are. The x-axis is right here. This is what I'm flipping my image over. Before I flip it, I need to grab my pre-image first and draw it. Put your points on. You don't have to wait on me. You should know how to graph points. -4, 2. 4.7. And 5.1. I always put my points on first, and I go back and label just so I can make sure my letters are outside my actual figure. So, got my points. That's A, that's B for me, and that'll be C for me. Sometimes when I label as I go, my letters end up inside my figure when I draw my lines for my figure. And yeah, I had some kids in the other class, like, they had problems, especially when you get 4 letters, they had problems connecting their lines. I don't know why. Connect them in the order they named the actual figure. They called it A, B, C, so I'm going to draw my lines from A to B, B to C, C back to A. Alright. So that's my pre-image. They want me to reflect over the x-axis. They say these are easy. You can always count for any reflection that you do. And if you don't understand the rules that I show you afterwards, I suggest always counting. Honestly, most of the time I count anyway, unless it's just a big graph that I'm looking at that's got like 25 going each way. And I don't think we'll ever do that to you. We may do it once or twice, but I don't know, testing nothing. So to do the count, all you're doing to need to understand is this is your line of reflection right here, the x-axis. You're trying to figure out how far away each point is from the x-axis and go the opposite direction that same amount. So going to the x-axis, A is 1, 2 spaces away from the x-axis. Go back down to the x-axis, go down 2 spaces, 1, 2. A prime. I'm going to line up under B next. Count up, see how many spaces away from my x-axis. 1, 2, 3, 4, 5, 6, 7. 7 away. Come back down to the x-axis. 1, 2, 3, 4, 5, 6, 7. B prime. C is 1 space away. Line, make sure you lined up under that. Go the opposite direction 1. C prime. Yeah. Then connect. So that should be your image after reflection over the x-axis. It should look like a reflection too. It should look like a mirror image if you did it correctly. Then after that, you need to give me your coordinates of your new figure. DJ, can you read those coordinates for me? A prime, where is that at? -4, what? Okay. B prime. Say it again. B prime, C prime, do all of them. Try that again. They're telling you. It's 4 -7, man. You might want to look at that again. And then C to the right 4, which is positive. Down 7. I got you, buddy. C prime. 5 -1. So now that I reread these out, I want you to compare them to your original coordinates. Look at these coordinates in your originals. You should see what happened. Look at your original coordinates, look at these. Somebody come up with a theory. Oh, come on. I want to know what happened with the coordinates. Jeannie. Yeah, good. When you flip over the x-axis, your y-coordinate is opposite. You just change the sign on it. I don't want to say negative because I don't want you to think we're turning everything negative, because it's already negative. It's gonna turn positive. Yeah. So say if we had the image down here and we had to flip up, that means all our negative y's will turn positive. So reflection over the x-axis, the mapping rule. XY maps to X, which stays the same. That's why you just write an X, and then a change in Y. Doesn't mean negative Y, it means a change in Y. If your Y is already negative, you're gonna turn that positive. In this case, all our Y's are positive though, so they just all end up turning negative. Alright, sliding on to the next one. This one's a rectangle. We're taking that over the y-axis. There's a rule for this one too, and you probably can figure it out based off what we just done on the last one. But I want to go through and show you how to count first still, because you can always count even if you can't remember the rules. Y-axis, that's what we're flipping over on this one. Graph your image. 1, 2, 2, 5, 8, 3, 7, 0. This is P, Q. I cannot write a Q. R, S. Let me go on a bathroom pass. So that's my rectangle on the graph. They want me to flip that over the y-axis. Shouldn't be hard for y'all to do. Like I said, I go in the order in which my letters were called. So I'll do P first. P is 1 to the right of the y-axis. I'm going to the left 1. Call that P prime. Go up to Q, line up with that. Q is 2 to the right. Go to the left 2. Q prime. Line up on R. R is all the way over, so it's 8 to the right. Go back to the axis, go all the way to the other side, 8 to the left. R prime. Then line up with S. S is 7 over. If you want to count it, 1, 2, 3, 4, 5, 6, 7. Going back to the left, 7. S prime. Just flipping images. Don't make this harder than what it has to be. It's the one, number 3 and 4 in the back is what kids struggle with. We're going to find out in a second too if y'all going to struggle or not. They're not even hard though. Alright, so coordinates. Trent, you got the coordinates for me, or can you get the coordinates for me? Go ahead, I'm listening. -1, 2. -2, 5. My pen dying again. -8. 3, -7, 0. Y'all notice what happened this time? Yeah. This time it was the X. Since we flipped over the Y-axis, our X values change. Well, the sign on our X, not the value, excuse me. Let me say that correctly. Sign on our X changed. Reflection over the Y-axis. Our mapping rule for that is XY. Maps to a change in X, comma, Y. I say if you memorize those rules, you can use them. It's just it just gets too congested doing that because it's two more rules I can show you for on the back, and then when we do rotations later on this week, there's rules for that too, and all of them are kind of similar. So you have to like really be good at memorizing that stuff to memorize the rules. I'd rather just show you how to do everything by hand. Honestly, most of the times I do too, because believe it or not, I mean, I forget the rules if I ain't touched it in a while. I just know how to do everything by hand though. Counting. Number 3 on the back. Now 3 and 4, there's no rules I can give you for these because these lines are not on the X or Y axis, and then not diagonals either. This one, triangle JKL, they want us to flip this over X equals 4. This is what yesterday was for, so you can automatically know where to put your lines in at. X equals 4. Is that a vertical or horizontal line? I hear horizontal and I hear vertical. Which one? That's the vertical line. Our point is going to be at 4 on the x-axis. Here. Vertical line right here. This is our line of reflection for this one. This one you have to draw your own line of reflection in. Black pen. Wait.
This one?
Oh yeah. How you put them out that quick? After that, graph your original image, JKL. 1 negative 1. 2, 3. 3 negative 2. JKL. Alright. Wow, big. It's the same as what we've been doing. You just need to understand that you're counting your stuff from the line of reflection, not from the X or Y axis. So I'm flipping over this line that I created. Start with J. That was my first point. From my line of reflection, J is 1, 2, 3 to the left. To flip over that, I need to go to the right. So go back to the line of reflection. Go 1, 2, 3. Make that J prime. Go up to K. Line up with that. K is 2 away from the line of reflection. Come back to the line of reflection. Go to the right 2. K prime. L was next. Line of reflection. L is 1 away. Go back the other line of reflection. Go the other direction 1. That is my image after reflection over x equals 4. Last thing I need to do is get my points. Where a lot of the kids were struggling and they had problems with this, they were messing up reading their points from the line that they drew in. Your points always go from 0, 0. So make sure when you read me your points, you start back at the origin and read your points. What's up? No. It's not, believe me, it's not going to work. Like, there's no rule I can give you for this, man. One girl, I swear she developed one like 2-3 years ago. And what she explained to me was so confusing. And I was like, nope. I don't know, just count for this. If it's a line that you have to draw in like this, you need to count. J prime, where is that? Thank you. K prime. Thank you. And L prime. One more time. 5 negative. Thank you. Alright. So, want to make sure you got a handle on this. Number 4. I want you to do number 4. One thing I'll help you with, putting in your line of reflection. Even though you should be able to do that on your own. Flipping the parallelogram CDEF across the line y equals 2. Y equals 2 should be a horizontal line at 2. Go to 2 on your graph. Put in your line of reflection first. And then put your image on and flip across that line. And give me your new coordinates. Alright. So number 5, next one. Triangle XYZ. With those vertices, they want us to reflect it across y equals x. This one, y equals x. It is one of your diagonal reflections. It's one of the ones you'll see most commonly too if we ask you on the test. Y equals x is a slope-intercept form equation. So to graph this line, you need an M and you need a B. Somebody told me back there, carry on, you know what M is? I know you. I thought you might have figured it out after we talked. Anybody else know what M is? Huh? M is 1, right? But my issue said that too. But I told her you gotta write it as a fraction though, because you need what? 1 over 1. All right, because you need a rise and a run. Well, how you gonna graph it without rise and run? And then your intercept. What's your intercept? What's your y-intercept based on this equation? 0. Good. So start at 0, 0, and then you count your slope from there. This is the reason you need 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. This is your slope of your line. It's going to be a perfect diagonal in the middle of your graph. I'm gonna try to line up, get my jump perfect. You should split each box down the middle. Alright. Once you get your diagonal on, go ahead and graph your points, X, Y, and Z. No, should stay the same size. Don't you writing in pen, Ralph? Don't try to go ahead of me, man. X, hold on. Y and Z. What's your question again? Oh, because the slope is 1 because the slope-intercept form equation, y equals mx plus b. In front of x, if there's no number there, you should know that it's a 1, yeah. And then you got to make it a fraction. Alright, pay attention on this one. I'm going to talk fast. This is a diagonal line. We can still count to this line. It's just that when we count, since it's diagonal, you can't count one direction and then count in the opposite direction. Because if you even look at this first one, well, not the first one, it'll stay on the graph. Like say X, for example. Let me count that for you. Count X to the line. It's 1, 2, 3 spaces away from the line, my X value. But if I keep going down, I'm going to end up all the way at the end of my graph, and that's not going to look right. I don't want to go down once I get to the line. Since it's a diagonal line, I want to go to the right. So I'm going to count down to the line and then to the right, the other direction. So 1, 2, 3, and then go 3 to the right. 1, 2, 3, here. This is where my new X will be. Yeah. And you'll really know you're going wrong if you do the Y that way. This Y is like, let me count it. From the line 1, 2, 3, 4, 5, 6, 7 up. I can't even go 7 down on this graph. If I go 7 down, I'll be off my graph. You have to go to the right. 1, 2, 3, 4, 5, 6, 7. This is my Y prime. From the line here to the Y. My line of reflection to the Y. Count how many spaces. And then the last one, Z. From the line to Z is 2 spaces. 1, 2. Once I get those, go 2 to the right. 1, 2. Was your Y in the right spot, Jen? I always felt like that was just the one in the wrong spot. If you do it right, it should look like a diagonal reflection. It should look like it diagonally flips over that line. If you did it right. Alright. Let's get the coordinates because there is a rule for this one. Probably going to be hard for you to remember, but I'm going to give it to you anyway. My X prime, and I forgot to put a prime on that X, my bad. I want to mark myself on. What's that? Negative, well no. Yeah, -2, -5. That's where it's at. Y prime for -3, and then Z prime 1, -1. I want y'all to look at these too. You already figured it out? Okay. Well, let them look real quick, Jenny, and then we'll, or Jeannie. Well, which one is Jeannie or Jenny? Jenny, my bad. Okay. Okay, go ahead. Yeah, your X and Y coordinates swap and flip. I say flip. So all they do is flip. If you want, and honestly, you can use that for the Y equals X. What you call it? You don't have to go through the whole count on this one if you don't want. If you can remember that on the Y equals X, all you gotta do is flip your coordinates. You can graph the other one successfully. So let me write that out for you. reflection. Let's spell reflection right first. Over y equals x. The mapping rule for that one is x comma y maps to y comma x. Don't mess with my video right now with foolishness. We almost there. This is a video going all right today. After this. Alright, last one. Let's do this one. This is y equals negative x. We're doing this square ABCD. Put your line of reflection in first. To do that, make sure you understand what the line should look like. Slope of this line is what? Negative 1 over 1. Intercept. So at 0, count negative 1 over 1, negative 1 over 1, negative 1 over 1. Alright, my diagonal's shooting that way this time. Graphing the square ABCD. Negative 1 up 3. 0, 6. Oh, shit. 0, 6. 3. I told you that shit. Imagine doing all.
I can't imagine doing this.
Sometimes we about to say, nah, I ain't gonna do it, but if I don't do it, they won't do the work. Gotta grade. No, I'm talking about just grading papers. Say it again. Are you talking about the car? What do you look like? Yeah.
It's weird.
It just feel weird. Yeah. Did I graph everything right? Yeah. Alright, I feel like my square a little off, but okay. Nice on, I guess. 3, 5. Is that 5? Yeah. I think it's the way I drew my lines. They got the same slope each way. Nah, it's good. I got the same slope each way. It's got me not feeling it. I guess it's right. Okay. I'm gonna roll with it. Alright, so we flipping over y equals negative x. Like I said, you can do the count. This time counting down my A, so 1, 2 to the line of reflection. Then, like I said, the obvious direction to go is to the left. 1, 2. A prime. Oh, that's pins. A prime. Then I do B next. 1, 2, 3, 4, 5, 6. And then go 6 over this way. What's the question?
What did you just do?
I counted from here to the line of reflection. 1, 2 spaces. And then I went to the left. 1, 2. And then do C next. 1, 2, 3, 4, 5, 6, 7, 8. So go 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. C prime. And the last one is D. 1, 2, 3, 4. 1, 2, 3, 4. This pen is dying rapidly right now. Last name, the coordinates. We should let Kamora do it. Shh. Hold on, I need my coordinates. Be quiet. Oh, I'm gonna have to go with another pen. That pen is dying. 3, -1. Okay. Shh. Well, I'm about to say, was the first one right? Man. Scratching out A prime. It's -3, 1, -6, 0, -5, -3, -2, -2. Yeah. So you can figure this rule out for this one too, but it's a little bit harder because some of these numbers are different. The best one to look at would be either A prime or C prime and figure out, well, A and A prime and C prime, and figure out what happened to the numbers. Go ahead. Shh, be quiet so you can hear. Be quiet. And don't put that up there. I'm writing a reflection rule on here for you. Yeah. Not necessarily turn negative though. There you go, opposite. That's a better word. So Jeannie said it or Jenny said it flips and the signs change, they turn opposite. That is true. If you look at our originals, the first one was -1, 3. Our new A was -3, 1. And then if you look at 0, 6, that became -6, 0. C 3, 5 became -5, -3. So it's XY maps to changing Y, excuse me, changing X. You flip and you change the signs. I know, that's why I'd rather you just count. Because it's like a lot of different rules you would have to remember. Huh?
If you want to remember it.
If you want to remember, if you want to go that way instead of counting, yeah. But you can always count and get them right.
All right, bro. You look like you look tense.
I need you again. Oh yeah. Hey, this was a decent video too.